Hello, Mr. Gazda here. I'm doing a quick rock review, and this is mainly geared towards the New York State Earth Science Regents, the Part D, or what's called the Lab Practical. So what we're going to do is you really want to say is the igneous, sedimentary, and metamorphic, and you want to give a reason why you chose that type based on an observable characteristic of that rock. Here we go. This here, what kind of rock is it? And why did you choose that kind of rock? Here we go. The answer is, it is an igneous rock. How do you know? It's the vesicular texture, all those little holes in there, or gas pockets. That's a good description as to why that is igneous. Next up, what kind of rock is this? And here, I have a close-up right here, if we could use that. There's a close-up right there. That is a sedimentary rock. And how do we know that? Because it has rounded particles that are cemented together. So rounded pebbles cemented together is a good reason that would be is noticeable to be sedimentary. Next up, the third one. What kind of rock is this? And here's a close-up here, if you could see that. And the answer is, it is an igneous rock because it has interlocking crystals that are randomly arranged. This is the hardest one I found for students. And I know I tend to really promote that interlocking crystals is not enough because metamorphic rocks also have interlocking crystals, but they are arranged in some sort of order pattern, flattened, think foliation, think banding. So the random arrangement is key. And again, this is the hardest one I've noticed for students to get right. What kind of rock is this? If you look at the texture, hopefully it came through in the picture. And it is an igneous rock. Why? It has glassy texture. Usually the glassy texture is very obvious, so that is lava that cools very quickly. Gives that glassy texture. What kind of rock is this? And you got to look closely. This picture may be, if you look here, all the black, the kind of layers here, if you can notice that, so look closely. So therefore, it's a metamorphic rock, and the reason you recognize that is because you notice banding, or foliation also works. Banding is just like extreme foliation. What kind of rock is this here? Okay, and you see those fish fossils in it, so therefore sedimentary rock because it has fossils, and sedimentary rock is really the only rock that has noticeable fossils like that. Okay, hopefully you can see this, all these little holes in here. What kind of rock is this? Igneous rock because of the vesicular texture, which is the gas pockets, as gases dissolved in the lava, that the lava solidifies so quickly those gases didn't get a chance to escape, so they get sort of frozen in the rock itself. This one, here we will see, if you got to really look kind of over here, and therefore it is metamorphic because you can see the banding, or you even say foliation, but the band is really obvious there. What kind of rock is this? And again, in this red box, there's a close-up of it, and it is an igneous rock due to the interlocking crystals that are randomly arranged or not in any order, not in a pattern, not grouped together. That's number 9. Number 10, you got to look. Some students I know missed this. Look at this here and this here. Hopefully it comes through. That is like fossils of some sort of plant, therefore sedimentary rock due to the fossils that are obvious there. This, igneous rock due to glassy texture. Next up, ig, sed, or met. This kind of jumps out at you. It is metamorphic due to the banding that you see here. Here we go. This is igneous rock because of the vesicular texture, again, of the gas pockets, as I just described before. And we're on number 14, looking similar. This is a close-up of this as well. But these crystals are big, so you can actually see them, but this is even good to really show them. And this is igneous because of interlocking. Sometimes we use the word intergrown crystals, kind of like a three-dimensional puzzle, that are randomly arranged, or they're in no order, no pattern, not grouped at all, something such as that. This, what you're seeing here, is this rock here is going to be a sedimentary rock because of the presence of fossils. And this is an extreme close-up of a rock, but you see the black layers here, and then also the white layers too, in between the black. Therefore, metamorphic rock due to that banding that's visible. Or as I said, banding is just extreme foliation, so foliation will also work. 17, what kind of rock is this? This may be a little more challenging. I like that someone put a quarter in there for scale. If you see right here, what you have is those really thin layers. This is a metamorphic rock because this right here is the foliation that we're seeing. Hard to get in a photograph, and that does a decent job of it. Easier to see when it's a hand sample. But so metamorphic rock is the foliation. Now you could not say banding there because it doesn't have those sort of different color bands. But this is number 18. What kind of rock is this? This, if you look at these white particles here, and they're actually angular, but it is a sedimentary rock because we'll say in this case rounded fragments that are cemented together. Oftentimes, most of the time, they're usually rounded. This is more of a rare rock. This is a breccia, be angular, but with the cement in between. Will usually help if you could see it close up, which I don't have a close up of. So that's the end. I hope that helped. I'm Mr. Gazda, and good luck on the lab practical or any way that you may deal with rocks.